One major problem calculus tries to solve is finding the slope of a curve. Now we already have a slope formula, y2 minus y1 over x2 minus x1. But that is for a straight line, not a curve. Nevertheless, this formula can still approximate the slope of a curve if we pick points on the curve that are very close to each other. In fact, it gives us the exact slope of a curve if we pick 2 points right next to each other. And we can do that with the use of limits. So let's look at our function, y equals x squared, and let's try to find the slope at the point 2, 4. So in order to find the exact slope at this point, we need to use the point 2, 4 and the point right next to 2, 4 in our slope formula. And the only way to get the point right next to 2, 4 is to use a limit. So we will define the second point as x, x squared, plug that into our slope formula, and then take the limit as our second point approaches 2. So we end up with this limit, which represents the exact slope of y equals x squared at the point 2, 4. If you've set this up right, this will give us an indeterminate limit, which you can see how to solve in the Solving Indeterminate Limits video. We can generalize this formula by saying the slope of any function f of x at a point x equals c with this formula right here. Now suppose we want to make a function that represents the slope of f of x at any point, aka the derivative. Well, instead of picking a specific point on our function, we just need to generalize it. So let's go back to our function y equals x squared and pick a general point, x, x squared. And then we need to pick a point right next to it. And we do that by saying the second point is x plus h, x plus h squared. We put this in our slope formula, and then we make the second point right next to the first point by saying the limit as h goes to 0. Since h represents the difference between the 2 points, so as the difference goes to 0, we have points right next to each other. Again, if we do this correctly, we will have an indeterminate limit. You can watch me solve this one, but the goal of solving every derivative limit is to be able to cancel out the h in the denominator, and we apply similar techniques to solving the indeterminate limits. For a polynomial function like this, we FOIL everything out and cancel like terms. To be honest though, it's not important to know how to solve these limits. What's important is recognizing that the limit represents the derivative of y equals x squared. Again, we can generalize this formula for any function f of x and get the limit definition of the derivative. Boom.